we have some parts to make. And atypically for me, we are not gonna be making parts that are this big, we are gonna be making parts that are approximately this big. Though don't worry, there's still plenty of micro machining that's gonna take place on this little piece of titanium, or 5 of these pieces of titanium. So this is what we're making today. It's some sort of microfluidics mixer or maybe a heat exchanger. It's gonna be coming out of these sheets of grade 5 titanium. These are 100 thou thick. My part is 60 thou thick. For those of you that have been around since the carabiner days, you will know that material movement in titanium when you face off the top of it is wild, and it has been my machining nemesis for a long time. So I don't know how this is gonna go. I have 3 blanks cut. I have enough material here for about 6 more blanks after that, and I need 5 good parts. It is currently Saturday night at like 9 p.m. These parts have to ship on Monday before close of business. The catch is, if I need to order more material, I need to do that well, I guess I can do it tomorrow and pay for UPS red shipping, which costs me about $100. Also, the extra material I need to buy will also cost me a couple $100s. So if we scrap too many parts, I'm like several $100s in the hole. Last time I took a job like this, I covered some of my costs and my income for the job. So this job, 5 parts, it is paying $1,500. The material I've had sitting around in my scrap bin back there for a while, but if I had to buy the materials, it would be about $200. I didn't have to buy any tooling for this job, so the only other costs are just shop overhead, paying for the machine, paying for the shop. Oh, and it's not in my model right now because it was causing issues with my cam, but there's actually a hole connecting this little channel here to the outside of the part, and same on the bottom here. We'll cross that bridge when we get to it. Now, I would be shocked if I didn't have to do this like 6 different ways to get it right, but plan A is to lap one side of this flat and then use the super glue and tape method to do the cutouts on the top and just shape the dip. Then we can cut all of the surface features into the top before making some sort of fixture to mount it straight up and down and drill those side holes. But I just realized this is all of the super glue I have for this right now, and stores close in about an hour. So I'm gonna have to go run to the local Dollar General and get some super glue before I can even get started on this project. Never mind, Dollar General didn't have it, so we're going to Walmart now. So now that I'm done driving halfway across the city, we can try to lap down one of these plates. We'll see how flat we can get it. Now, I say lapping because I want to sound like one of the cool kids, like Robin Renzetti and the people who actually know what they're doing. But really, I have this glass sheet that should be pretty darn flat. I've never actually tested it, but in general, glass is relatively flat, and it's like 1/2 inch thick. So it should be pretty flat. And I have some silicon carbide sandpaper glued down to it. It's an adhesive back sandpaper, and so it just sticks on there really quickly and easily. I have found that basically whatever Windex or Windex equivalent cleaner you have laying around works pretty well to kind of moisten the paper. And then after that, it's just small figure 8s. Or any size figure 8s. I don't really have a good way of measuring this, but it seems reasonably flat. If you look at the reflection of the light, it's at least somewhat consistent. It doesn't seem like it's warped or bowed. And if I put it down here on the surface plate, it slides well and smoothly. There's maybe a little bit of a high spot or low spot, whatever you want to call it, right about here that I could take off. But I think we're talking less than a thou, because it really does kind of like glide over the surface plate. I wonder if I can, yeah, see, it kind of gets that air bearing effect, which I think means it's pretty close to flat. And I really don't have any super tight tolerances on this part, so I think pretty darn close to flat is close enough. Now we need to do the part that I've been avoiding. At this point, most of my fixtures are these nice little compact things on these small compact base plates. My super glue fixture is the one thing I haven't upgraded yet. So we have this monstrosity hiding down here on the bottom shelf. It's big, it's heavy, and it's ugly, and so I always avoid using it. Plus, we're gonna have to take off the mod vise and the flux vise in order to get it on the table. I didn't use activator this time like I normally do. I have heard mixed things about whether activator helps or hurts. I do think, to my understanding, it actually makes the glue bond stronger. However, it definitely makes it more difficult to get the glue up right the first time. So to be safe this time, I'm going to not use the activator, and I'm just going to wait half an hour before I run the program. To set my 0 point, we're going back to the very old school method of drawing lines connecting the corners on the stock, and I'm just going to line up an end mill with the approximate center there. I have like plus or minus an 1/8 inch in all directions, so even if I'm like very off, the part will still be on the material. So earlier I put a layer of tape down here. Now this piece of material is sitting on 2 layers of tape. The one that I taped to it, and then the layer here, and it's got the glue in between. By setting my 0 point on top of the tape here, theoretically, if all my tool heights and everything are good in my probing position, and my probe is dialed in, then theoretically, if all goes well, we should cut through half of the tape and leave the other half of the tape. Though now that I say that, I think I may have actually done some negative stock to leave, so we're probably going to cut into the fixture. But that's okay, this is a sacrificial fixture. Also, you may have noticed, I got a Renishaw probe, finally. After having this machine for a couple months, I just finally got a probe, and it has been life-changing. This is the tool that'll be doing the majority of our slotting. It's just a vanilla 1/32 inch 4 flute. All right, well, we should be good to cut. I have my feed and rapids down just in case. I don't know why I didn't do single block. All right, I'm gonna go to 100% feed. We're gonna stay at lower rapids. We're cutting, sounds good. Load is good. All right, we just switched from ramping to adaptive. We're still at like 25% spindle load. And we're pocketing. Well, I'm gonna sit here and watch it for a bit, but really this is like a 2-hour program. It's like midnight, it's like 1. So I'm gonna go to bed and let you guys watch it for me. So we're gonna go into time-lapse mode. I will stick around for a while, don't worry. And I have all kinds of tool breakage and detection and stuff set up, so it should be safe, but enjoy the time-lapse. Well, that one didn't exactly go as planned. And yes, I stuck around long enough to see if it failed last night. And it did. So upon reviewing our evidence that was left behind, it was actually the tape against the pallet that failed. So you can see with this lovely mess here, this tape that was touching the pallet is basically completely loose. There is still glue and tape on the back of this thing. And I pulled this off of that piece of tape earlier. So need to try this again. Now I have to confess, I know the reason this didn't work, and the reason is me. Both past AJ and current AJ. So last night when I was laying that first layer of tape down, the one that's touching the pallet, I didn't use a strong degreaser like acetone or alcohol on it. I just used, multi-purpose cleaner because it's what I had on hand. And I didn't want to deal with the fumes of acetone. It was basically just laziness, and it came back to bite me. Past AJ made a mistake with how he designed this pallet. There's a few things I would do differently. First of all, I would set it up so that the little glue grooves that are down here do not connect to the whole pallet together, because that means once coolant starts to get underneath one portion, it starts to get underneath the whole pallet and the tape comes up. So in the future, I would have I would have a bunch of squares or circles or something, but they wouldn't all be connected. Maybe in smaller 1-inch grids, or maybe just not at all, just separate squares. I also wouldn't make it out of aluminum. I think, and I don't know, I don't have any scientific studies behind this, but I have a hunch that things don't stick to aluminum as well as they stick to other materials. Like, I think tape actually sticks better to like steel or brass than it does to aluminum. Something, something, oxidation layers, something, something. So at some point I'm gonna redesign that fixture and make it probably out of mild steel, but today is not that day. So at this point, I'm gonna take this one, I'm gonna put this back on the pallet and refine the center point on this the same way I did before. There is a little tiny gash on this one from where it came loose, but it is really minor, and I think it is less than the stock to leave that I had on my roughing operation. So I'm gonna put this one back in there, I'm gonna run the program again, and I might change from a 3/16 inch rougher to do the face of it to a 1/8, just to reduce some of that tool pressure. This one may or may not end up being scrapped because of that tiny gouge. I think it's fine, but it is possible that this is gonna be scrapped. And a lot of the times, normally I would just throw it away and start a new one. But on this project, I know that I'm probably gonna be scrapping at least one more part for some other dumb reason. And I might as well make that dumb mistake on the part that I've already made a dumb mistake on. So I'm just gonna put this one back in. All right, let's do this whole thing again. All right, it seems to have finished. There's some big burrs, but otherwise it's looking all right. My grooves are there. There's some ugly surface finish there. Possibly, yeah, it warped. So we definitely had some warping take place here that did some weird things. So there's supposed to be this very shallow ring here, and you can kind of see the line there. It's only like 1/4 thou deep. Right there, it's fine. Over here, it kind of appears to be non-existent. There's also this like thicker ring that goes around the outside, and that's not supposed to be there at all, and I don't really know why that is there. But I think it has to do with, again, the sheet warping as we cut it. There's also some ugliness in here, which again is a sign of the sheet warping, which is what I was afraid of. And if I kind of push down, I can see some flex in it. So this part is almost certainly scrap. But I'm going to rerun the finishing pass just to see what happens. Yeah, okay, I still don't like this one. I need a pry bar. This should work. There's no way this one's gonna be in spec because of that warping. So, it is what it is, we gotta make another one. Upon further inspection of this thing, it's actually not as bad as I first thought on the machine. Now, it's definitely out of spec, like way out of spec, don't get me wrong. But it wasn't quite as warped as I thought. It is about 10 thou undersized on this side, and then about 6 thou undersized on this side. So yes, the whole thing is too far undersized. My tolerances are ±5, and I aim for ±3 on everything. So it's out of spec. But I was afraid the warping was like, when I was looking at the machine, I would have told you it was like 20 thou. And it's not 20 thou. It's like 4 or 5 thou. So if my work coordinate system had been right, for some reason that got set wrong, maybe because I need to dial in the probe better, but for some reason that was off, and if it had been dead on, I would have been like +2 or 3 on one side and -2 or 3 on the other side, which would have worked. There is also a noticeable mismatch on the tool path, like right here on the outside. I can feel it with my fingernail, and that was definitely caused by the warping. But we're closer than I thought we were. So we just need to get the rest of the way. I'm going to do an experiment with this next part. And I was running this out of This stock here, this is 100 thou thick. I'm gonna try going to this stock, which is 70 thou thick. That means I'm only removing 10 thou from one face of this. My theory is because I'm removing less material, that's less ability for the material to warp. I don't know if that's actually gonna transfer to practice, but we'll give it a shot. So this one was better, but I'm still not quite happy with it. It's a little bit oversized, and I think I can actually lap it down to size if I need to, but I'm gonna leave that one in reserve because I'd rather not spend an hour with sandpaper to get it to the right size. I've been talking to people, and I think I've learned some things. I think my problem is this palette. Stuff just don't stick to it anymore. And our theory why is that I have all these holes. Some of them are tapped, some of them aren't. And we think the coolant and stuff has built up in there, and it's built up in the grooves here. And that is just making it impossible to clean, and so the tape isn't sticking to it. I originally designed that palette to glue directly to without going through the layers of tape, and that just ended up not working well for a number of reasons, one of which being all of the tapped holes that just got filled with super glue. So I think I'm just gonna be better off by grabbing a piece of aluminum, which I can't lift with one hand, this piece of aluminum here, and clamp that in a vise and face it off and then glue directly to that. I think that will be better going forwards. We finally have a working process. Hopefully it's reliable. We'll find out that soon. Last night, I kind of treated the machine like it was a newborn. I woke up about every 2.5 hours to come and load up a new part. Switching to just like the flat machined aluminum base plate instead of the pallet has made a world of difference. The first time I ran the program last night, the part came out a little bit thin. I just had to adjust my work offset. That was the first one on the new fixture design. The second one, I ran it. I wasn't watching the machine. I went and slept while it was running. And when I came back, it had a broken tool. Of course, it was the 1/32 inch end mill that does all the slots. And there's not really a good way to start that slotting tool path in the middle. So I had to rerun the whole slotting tool path. And that tool path is like an hour and 50 minutes of like the 2.5 hour runtime. It's just like a large percentage of this entire part. And so basically it would have been the equivalent of just losing a whole part cycle time. So, but then it finished off and the part was good. So we got 2 from last night. We're running another one now. No, we only got 1 from last night. We got 1 from last night after waking up every 2.5 hours for the whole night. But we have 1 more on the mill. At this point, they should all just come out good. So we got 1 more on the mill. I need 5. So we have 2 when this is done, which means I have like 8 hours of machining left, plus the second and third ops. So we might be tight timeline-wise, especially since today's the eclipse day, and I need to be hanging out with my family for it. So these parts, of course, need to ship today. So I'm just going to do everything I can to keep the machine running. If we do that, we should be fine. And then after the eclipse wraps up at about 4 or 5, I can knock out the second operations before everything closes down at 7. FedEx closes at 7. So it'll be tight, but theoretically these can still ship on time. So now that we have a nice pile of these little titanium coasters right there, we need to drill the holes in the ends of them, which is not really something that I am looking forward to doing because these are awfully thin and there's no good way to index them to make sure that they are in the right orientation relative to the drill bit. My plan A, is just to clamp them in my vise with some support and then use a indicator to just sweep them in and then probe to find the top dead center so that we can drill them. So let's hope that works. So this right here is the hole we need to drill. It's about a 1/2 inch deep. It comes from the edge here. It's 1 millimeter in diameter. Now, the thing that I did not fully take into consideration until now is it's like half off of this material on the bottom. I don't think the drill is gonna like that very much, but I'm gonna try one first just to see. This is probably a good example of where the mod vices aren't ideal, but the setup will work. We have 1, 2, 3 blocks providing some support to the part. And then basically from here, it's just a whole bunch of probing to get the top dead center. Except I did just realize there's not really enough room to get an indicator in here to get this level. So maybe I'm gonna move these blocks onto their side. Okay, never mind, my indicator trick is not gonna work. There's no way this is gonna fit in there. Even if it did, it would be almost impossible to get this aligned. So let's make some sort of alignment block. So I found a way that is lazy and may or may not work. So we'll try this first with this test part. I have 2 dowel pins, 2 very small dowel pins sitting in this groove here. I'm going to super glue those in place, and then when I go to load it in there, I can use those to rest on the 1, 2, 3 block before I tighten it down. And that should get me my alignment. That actually seems to have worked rather nicely. Our first step here is to set the approximate position of our work coordinate system so that the machine knows where it needs to be when probing in the final work coordinate system. So I've already just kind of eyeballed X and Y, and now we are going to do an actual probe for Z. Now we should be able to run our full probing routine, and hopefully nothing terrifying will happen. And that's it. It's super hard to see, but I assure you there's a hole there. I was afraid that'd be much more difficult than it turned out to be. So I guess now we just get to do this 9 more times, since there's 2 sides to each of these that need it, and I have 5 of these. I'm feeling confident, so let's go into production mode. It's been a few weeks now. Customers have their parts. They're happy with them. So I guess it's the end of the video. Bye.